Hello everyone, today we will talk about electronic countermeasures. And before the start, we should mention that a good way to understand ECCM is going on with and observing it with examples. And it's really very related with ECM. So in this slide, we will not just talk about the topics and definitions, we will also look for applications and talk about real-life techniques. So let's start with what is ECCM? Is a part of electronic warfare which includes a variety of practices that attempt to reduce or eliminate the effect of electronic countermeasures on electronic sensors aboard vehicles, ships, aircrafts, and weapons such as missiles. So this is the general definition of ECCM. But how did it all start? Let's take a quick look from the beginning through the electronic countermeasures. And after the discovery of radio waves by Henry Hertz in 1884, electrical signal transmitting techniques has become its new form, which is wireless. And here you can see Hertz experiments, and we have two mechanisms in here, far from each other. They are not touching to each other, so they are completely isolated. By the way, they consist of little tiny spheres at the end of their wires. So when electrical current passes through, for example on the first mechanism, an electric spark will jump from one sphere to another. The exciting thing about is another electric spark will jump from one sphere to another on the another mechanism, even there isn't any current flow on its wires. This is because an electric spark creates an invisible wave of energy that propagates outwards in a spherical pattern, and when this wave passes through any piece of metal, such as nearby wire, it causes it to vibrate electrically and generates electrical current in the wire, known as electrical induction. It was later discovered that these were actually invisible light waves known as radio waves. And the first telegraph network was invented by Samuel Morse. By the way, telegraph, which uses a powerful battery that sends electrical pulses through an antenna. Whenever a key is pressed, we will send ones and zeros, and radio wave generated by each of these electrical pulses ends in another device that has an ability to analyze sending wave, which we know it as receiver at the end of the telegraph. And later on it was replaced by the Graham-Bell telephone. And you can figure out that the wireless systems are stepping inside to our lives year by year while technology has been evolving. In 1895, after the invention of telephone, Marconi demonstrated the first radio transmission, and later on the following years, militaries of nations successively invested significant resources for developing networks to use in the battlefield, and ad hoc wireless networks have been built. I said the wireless systems are stepping inside to our lives year by year on the previous slide, but not only the daily life routines, also it had been prepared to use in various areas such as military, you can see, because even on war, for example, during the battle, communication and taking advantages of technology is very important. These technological advantages take us another and new side of war, which is electronic warfare. And electronic warfare, we can define it as it is any action involving the use of electromagnetic spectrum or directed energy to control the spectrum, attack an enemy, or impede enemy assault. The purpose of electronic warfare is to deny the opponent an advantage of and ensure friendly unimpeded access to the electromagnetic spectrum. Also, EW can be applied from air, sea, land, or even in space by manned and unmanned systems, and can target humans, communications, radars, or other assets such as military or civilian. And about the history of electronic warfare, in Russo-Japanese War, one of the Japanese cruiser, Shinonamaru, had located the Russian Baltic Fleet and was communicated the fleet's location by wireless to Japanese headquarters. A Russian warship at the other side, Orel, requested permission to disrupt the Japanese communication links by attempting to transmit a stronger radio signal over the enemy signal, hoping to distort it at the receiving end. But Russian admirals refused the advice and denied the permission to electronically jam the enemy. Pay attention, this is not the first application of electronic warfare, this is the first idea of electronic warfare because pitifully Russian admirals refused the advice and denied the permission. And as you see in an old Russian newspaper, a Russian soldier is hitting a Japanese soldier actually on his cheek, but the battle report was directly opposite of it because the information that Japanese ships gained led them into a decisive victory, and the battle report was humiliating for the Russian side. And it's the idea of the first idea of the electronic warfare and very early history of electronic warfare, we can say. During World War II, the Allies and Axis powers both extensively used electronic warfare. Navigational radars had gained in use to vector bombers to their targets and back to their home base. The first application of electronic warfare in World War II was to defeat those navigational radars. Chaff was also introduced during World War II to confuse and defeat tracking radar system, and we will talk about Chaff on the following pages.
Electronic warfare has a three-part. Firstly, electronic support measure is on the name provides electronic support. Electronic attack part is electronic countermeasures. Successfully undertakes the of counterattack. Electronic protection part is electronic countermeasures, which is the art of defense emerged upon this attack. Electronic warfare in today's military environment in the complicated figure as you can see, figure involves the military use of electromagnetic energy to prevent or reduce an enemy's effective use of electromagnetic spectrum while protecting its use for friendly forces. Electronic support measure is involving actions taken by an operator to detect and identify sources of intended radiated electromagnetic energy. The purpose is to provide immediate recognition and targeting of threats. In the figure, Royal Air Force Manwith will provide communications and intelligence support service to the United Kingdom and United States. United Kingdom flies intelligence planes close the battlefield areas at regular intervals. They manage to protect their intelligence through economic methods. Electronic countermeasures involve the offensive use of electromagnetic energy or anti-radiation weapons to attack or destroy enemy combat capability including human life. We see inspecting an ANALQ 184 electronic attack bot in this figure. The ALQ 184 is a self-protect electronic countermeasures bot used in US Air Force tactical aircraft, generally using an F-16. The ALQ 184 increases effective radiated power, reduces countermeasure response time, and improves reliability. Jamming can be performed on communication system or radar system. In the case of anti-radiation weapons, many times this includes missiles or bombs that can hone in on radio or radar signals and follow, thus destroying the system broadcasting. We see the applications of ALQ 184 in the photo, positioned in the middle of the F-16 Firejet. Electronic countermeasures involve actions taken to protect friendly forces from any effects of the enemy. Shortly, electronic countermeasures is the ability to counter electronic countermeasures. Electronic countermeasures is the method by which you endeavor to combat the electronic countermeasure system of the enemy by either making your equipment electronic countermeasure resistant or by using techniques to nullify his jamming or decoy system. Electronic countermeasure has a two parts as anti-passive and anti-active electronic countermeasures. Passive electronic countermeasures transform or redirect the wave energy, chaff or chip, corner reflection, radar absorbed materials. Active electronic countermeasures are implies an addition of energy, jamming and deception. Active decoys. Electronic countermeasure has two parts to resist them. Anti-electronic countermeasures for passive and active. Objectives of electronic countermeasures: prevent of radar saturation, engagement of signal to jamming ratio, discrimination of directional interface, rejection of false targets, maintenance of target tracks, counteraction of electronic support measures, radar system servability.
And as a quick brief of radar, as a reminder we can think, shortly, radar stands for radio detection and ranging. Its capital letters come from this. It's based on echo and Doppler effect. It measures distances, velocities, and estimate direction. Echo allows us to know the position of the target, while Doppler effect provides information about the velocity with its frequency. And also we have two main interferences about radar, which we call noise and clutter. While noise represents the received variation of the signals, clutter means the unwanted echoes on the panel. So let's continue with what exactly ECCM applications are and understand them well with real-life techniques. For example, here we are dealing with an ECM operation which is jamming, and we have a jammer interferer in here which sends jammer or spoofer signals to the signals with aim to get destructive interference as to signals coming from the satellites to the aircraft. And we have a representation about the interference in here. For example, we have two waves, wave X and wave Y. When these waves are actually the same, they will amplitude each other and they will amplitude each other out, and we have a better signal in the resultant wave as a resultant wave. This is a good type of interference which we call it as constructive interference because an amplitude modulation will be occur in here. But when one of the wave, for example wave Y is shifted a half wave cycle, and as you can see they are opposite of each other, so they will cancel each other out and we will have no signal at the receiver. lost signal at the end, and we call it a destructive interference, also jamming interference, which is a bad type of interference. Actually, ECCM against jamming are very simple and is about just increasing the radio transmission power to burn through the enemy's jamming attempt. And another application about ECCM is ECM detection and radiation homing weapons. This includes the use of sensors which can recognize attempts to deceive enemy radars like chaff and disregard them. This can be taken even further with the radiation homing weapon systems like missiles, which can detect and target radio emissions themselves, known as anti-radiation missile. Also, some radiation homing weapons are designed to redirect towards the source of enemy jamming signal if the interference makes it impossible to hit their original target. Others are specifically designed to seek out the location where the enemy signal is emanating come from. This is almost like applying the principles of a martial art, for example judo, to electronic warfare, turning the enemy's ECM attack against them. If the enemy uses their jamming capabilities, they are also giving away about their position and opening themselves up to a kinetic counterattack. So let's explore some more sophisticated methods for overcoming ECM. But first, we need to know what is masking. And simply we can think masking is an operation that makes the target to avoid detection and radar signals, like a camouflage. We can also think it as a makeup, but not to get attention, of course. And here we have F-117 Nighthawk, the first operational aircraft specifically designed around stealth technology, and it has various models such as B2 Spirit, and we know them in Turkish as Hayalet Uçak, and in English they are stealth aircrafts. They are designed to avoid detection using a variety of technologies that reduce the reflection or emission of radar, infrared spectrum, visible light, radio frequency, and audio, collectively known as stealth technology. The main applications on these aircrafts are avoiding sharp corners and flat surfaces, which have successful reflection for radars on aircraft design like in this picture, helps successful reflection. And the other one is using beam absorbers, the special materials to reduce the amount of reflected energy from aircraft to radar. And ECCM to overcome it is actually again very simple, is the using multiple receivers, because you easily can think and understand using multiple receivers will increase your probability to detect, your increasing your chance to detect against chaff or reflected corners like this. And we can say that the multistatic radars allows to characterize better aircrafts.
Frequency hopping split spectrum is the transmitter that switches the frequency of the carrier wave in a random fashion across a wide spectrum. This makes it much more difficult for an enemy force to jam the signal. Also, frequency hopping split spectrum is usually used along with encryption for an added layer of radio communication security. It is also useful for jamming across multiple frequencies and reducing its power. The main idea and usage of free spectrum technique allows signal to be spread over a wide enough spectrum to make jamming of such a wideband signal difficult. I will explain the side lobe blocking. When jamming is strong enough, the radar receiver can detect it from a relatively low gain side lobe. Jamming can be seen in direction other than where the jammer is located. To combat this, an omnidirectional antenna is used for a compression signal by comparing the signal strength as received by both the omnidirectional and the main antenna. Signals can be identified that are not from the directional of interest. These signals are ignored. Polarization can be used to filter out unwanted signals such as jamming. If a jammer and receiver do not have the same polarization, the jamming signal will incur a loss that reduces its effectiveness. Pulse comparison is a technique that consists of modulation the pulse of radar signal transmission and then cross-correlation it upon reception. There are different methods of pulse comparison, but for electronic countermeasures it is known as chirping. Aside from power loss to the jammer, radar receivers can also benefit from using two or more antennas of differing polarization and comparing the signals received on each. This effect can effectively eliminate all jamming of the wrong polarization, although enough jamming may still obscure the actual signal. This form of pulse compression is highly resistant to jamming and used in ESA radar systems. Using this technique, the frequency of a radar signal is changing like how the sound of bird can change within an individual chip. Main points of ECCM: prevention of radar saturation, reinforcement of signal to jamming ratio, discrimination of directional interference, rejection of false targets, maintenance of target track, prevention prevention of electronic support measures, radar system survivability. Now we have a question. What is the main difference between electronic countermeasure and electronic countermeasure? ECM can be directed at aircraft, ships, sensor or weapon systems like radar-guided missiles for offensive purpose. ECCM, on the other hand, is about defending against ECM techniques and rendering them ineffective.
Another question is, what does burn mean in electronic warfare and when did the first idea of it come from? Actually, it means transmit a stronger radio signal over the enemy signals to distort it at the receiving end. And the first attempt, an idea of it was on the Russo-Japanese War. Also ECCM applications. In ECCM applications, increasing radio transmission power is simply burns the enemy's jamming signal.
The last question is, what is the one basic use of electronic countermeasure against detection track technology such as stealth technology or chaff? Answer is increasing number and using multistatic radars as multiple receivers allows to characterize better aircraft. And our references are here. Thanks for listening us.